Have you ever looked at a map on your phone and seen that little blue dot just jump around, by a few meters? For most of us, that's no big deal. But what if your entire business relied on knowing a position down to the width of a coin? Well, that's exactly what we're diving into today. The incredible technology that shrinks the world of positioning from meters all the way down to centimeters. So, here's what we've got on tap. We'll kick things off with a meter-level problem, why standard GPS just isn't enough sometimes. Then, we'll introduce the centimeter solution, RTK. After that, we'll break down how it actually works, see it in action across different industries, and finally, we'll wrap up with the key advantages that make this tech such a game changer.
Okay, so let's set the stage here. The satellite navigation systems we use every single day, what we call GNSS, they're absolutely amazing pieces of tech. But for professional work, think things like precision farming or autonomous drones. They have some serious limitations that create a pretty big accuracy problem.
And here is the gap we're talking about, plain and simple. Standard GNSS gets you in the ballpark, somewhere within 1 to 5 meters. That's about the size of a small room. But RTK technology? That narrows it down to centimeter-level accuracy. It's the difference between being somewhere on the street versus being exactly on the painted line. It's a huge leap.
So how in the world do we bridge that gap from meters to centimeters? Well, the answer is a technique that doesn't replace GNSS, but instead it basically supercharges it. So let's meet the solution, RTK.
What does RTK stand for? It's real-time kinematic. Now, the core idea behind it is actually pretty straightforward. It uses a fixed point on the ground, we call it a base station, to figure out and correct for errors in satellite signals. And the best part, it does all of this instantly, in real time.
If you only take one thing away from all of this, let it be this quote right here. This is the whole value proposition in a nutshell. It's not just about being way more accurate, it's about delivering that unbelievable accuracy on the fly, as things are happening.
Okay, so how does it really work? It might seem like magic, but I promise you, it's just a really elegant and clever system. Let's break down the core components that make this incredible precision possible.
The whole RTK system is kind of like a three-part harmony. You've got a stationary reference point, a mobile unit that needs that super precise location, and the link that connects them. Let's take a look at each one.
First up, we have the base station. I want you to think of this as the anchor of truth. It's set up at a location where we know the coordinates with absolute precision. So it listens to the same satellite signals as our moving device, it compares the satellite's calculation to its own actual known position, and bam, it instantly knows what the error is.
Next, we've got the rover. This is the device that's actually on the move. It could be on a drone, a tractor, maybe a surveyor's pole. Now, the rover is doing two things at once. It's listening to the raw, kind of messy signals from the satellites, and it's also listening for that critical correction data being sent from our trusted base station.
And what connects the base station to the rover? That's the data link. This is the vital communication channel, often using something like radio or a 4G/5G network that zips those crucial error corrections from the base over to the rover, making sure the whole system is, just like the name says, real time.
So, let's put it all together in a simple little loop. Step 1, the base station calculates the error. Step 2, the data link sends that correction. And step 3, the rover applies that correction to its own data and spits out a super precise coordinate. It's this constant, fast-moving loop that makes the magic happen.
Okay, so that's the theory. But where does this technology actually make a difference out in the real world? Let's take a look at how this level of precision is totally transforming some key industries, often with specialized hardware built just for the job.
Let's start with the world of drones, or UAVs. For things like aerial surveying, checking on infrastructure, or even package delivery. Knowing your drone's exact position isn't just nice to have, it's absolutely non-negotiable.
And this is where the specific hardware really comes into play. See, for a drone, every single gram counts. So the solution is RTK modules like these that are designed to be incredibly lightweight and compact. They give you that critical accuracy without sacrificing precious flight time or the ability to carry a payload.
All right, now let's head from the sky down to the farm. Precision agriculture is all about efficiency, right? Using exactly the right amount of resources, exactly where they're needed. And to do that, you have to know precisely where your equipment is in a massive field.
One of the biggest challenges on a farm can be just getting a signal, since cell service can be pretty spotty out there. That's why RTK systems for agriculture are often built with multiple ways to communicate, like having both 4G and really robust radio links. This makes sure an automated tractor never loses its connection, whether it's planting seeds or applying fertilizer with pinpoint accuracy.
Now, in surveying and mapping, accuracy isn't just a feature. It is the entire point. RTK has completely changed how this work gets done, making it both faster and way more precise. Surveyors are often working in really tough environments, from busy construction sites with tons of signal interference to remote, rugged terrain. For them, robust performance is everything. The hardware they use is specifically engineered with powerful anti-interference technology to make sure it delivers reliable, trustworthy data no matter what the conditions are.
And finally, let's look at the rapidly growing world of automation. From warehouse robots zipping through tight aisles to all kinds of Internet of Things devices, the need for precise location awareness is just exploding. For these kinds of applications, it's all about integration. You have to fit powerful technology into a really tiny package. That's where these ultra-compact RTK modules come in. They're perfect for embedding into smaller automated guided vehicles, or AGVs, and other robotic platforms where every single millimeter of space counts.
So we've seen how RTK works and where it's being used. But what are the core tech advantages that make it so reliable for these really demanding jobs? Let's quickly break it down.
When you look at them side by side, the difference is just night and day. We go from meter-level to centimeter-level accuracy because we're not just passively listening to satellites anymore. RTK uses a whole system, satellites, a base, and a data link to actively correct errors. It's really just a different class of positioning altogether.
So what this all means is that modern RTK modules are just packed with features built for the real world. They can track multiple satellite systems at the same time to get a better signal lock. They use advanced tech to fight off interference. They're ready to work in less than 7 seconds. And they offer flexible ways to communicate. This isn't just about accuracy anymore. It's about being reliable out in the field.
And that really brings us to our final point, which is more of a question for you. When you can go from guessing within a few meters to knowing your position within a few centimeters, what new possibilities does that unlock? How will that incredible level of precision transform the way you work?